Hi, grade 6. This is the video for your practice test form 2C for chapter 1. I am looking at problem number 1. I'm not going to do problem 1, but I'm going to do one similar to number 1. So if you pay attention, it should make doing number 1 a little bit easier. So what if I have a situation in which December a theater makes $15,000? And what if I know that in January they're going to make triple that amount? How would I figure out what triple that amount is? Wouldn't that be 15,000 times 3? So in January they're making $45,000 because that's triple the amount. Triple means multiplying by 3. And then it says, use the four-step plan to find the expected number of people that will attend during the first week in January if tickets cost $5 each. If the tickets cost $5 each. Well, what they're saying here is, I've got a certain amount of people, I don't know how many people that is, but they're spending $5 each, and we're bringing in $45,000. And the question is, how do we figure out what that P is? The amount of people. Because that's what this is talking about. The number of people. How do we figure that out? Well, isn't that a division problem? 45,000 divided by the 5. To solve for multiplication, we're going to do a division problem. 5 goes into 45 9 times. We're going to have to do a bunch of 5 goes into 0 problems, right? 5 goes into 0 again. 5 goes into 0 again. Do you notice how it has to be 9,000 people? Because 9,000 times 5 is 45,000. So in my example, the answer is 9,000 people. And so I write that answer, I put on a label, and I circle it. That's a way you can do number 1. Number 1 is not the same number. They use 17,500, but to solve it, you can use the same method. How can you solve number 2? Write the power of 4 to the 5th power as a product of the same factor? I'm not going to do that one, but I'm going to do 8 to the 3rd. It's simply 8 times 8 times 8. Done. They're not asking you to solve it in number 2. They're just asking you to write it as the product of the same factor in number 2. Look at number 3. Number 3 is a little bit different. 3, they're saying evaluate 2 to the 7th power. I'm not going to do 2 to the 7th power, but I will do 2 to the 5th power. What would it mean to evaluate this? It would mean first write it like this, and then solve this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So with this one, problem 2, you don't have to solve it. You just write it as powers, product of the same factor. With this one, number 3, you solve it. Look at number 4. How would you write that as exponential 4? Well, you got 3 times 3 times 3 times 3 times 3. I'm not going to do that one. I'm going to do this one. How would you write this one? 4 to the 3rd power, because there's 3 4s there. How about numbers 5 through 8? I'm going to write one similar to number 8. I'm going to write 8 plus the quantity of 10 minus 6 plus 5 to, let's go to the 2nd power. How would I do that? Well, first I do all the parentheses stuff first, from left to right. Notice, 10 minus 6 is 4. 4 plus 5 is 9. Now, do I do the adding next, or do I do the squaring next? The exponent next. I've got to do the exponent, and I get an answer of 89. You got to follow the rules of the orders of operation. Do the parentheses stuff first, then the exponents, then the multiplication or division from left to right. then the addition or subtraction from left to right. How about something in 9 through 12? If I wrote on the board 8b minus 5d, how would I solve that? Well, in the problem, b is 6. So I'd write 8 times 6. And in the problem, d is 5. So I'd write 5 times 5. Let's multiply and subtract. In this case, we get 23. Similar to the style of problem you see there. Now let's look at 13 and 14. What if I had a problem like 13 and 14 where somebody wrote t plus 2 equals 9, and then they put this, and then they put 3 choices like 5, 6, and 7. Which one of these fits here to make this a true statement? If you said 7, you'd be right. 7 plus 2 is 9. How about 15 through 17? Let's try what I think might be the hardest one. Number 16. I'm going to do one similar. What if I wrote 8 equals blank divided by 3, w divided by 3? Let's think about what this is really saying. If I take a number and I divide that number by 3, I get an answer of 8. Another way to write this would be this problem. What multiplication problem uses 8 and 3 in it? Well, isn't that 3 times 8 equals 24? Let's try that. Is 24 divided by 3 equal to 8? Yes, it is. Our answer is that w is 24. W is 24. Let's look at number 17. It says Rita swam 3 more laps than Lynn in the last swimming team practice. Lynn swam 14 laps. Rita swam our amount of laps. Write an equation and solve. So what does that say? Rita did 3 more than Lynn, right? Rita did 3 more than Lynn. That's what it says. And then it says Lynn did 14. We're supposed to write some sort of equation. Well, what's the unknown in this problem? Isn't the unknown Rita's amount? Because we know what Lynn did. Lynn did 14. Second question, who swam more, Rita or Lynn? Isn't it true that Rita swam more? So if you know Lynn's amount, couldn't you add a certain amount to it to get Rita's amount and then figure out what Rita's amount is? That's what you got to do here. Look at number 18. Define the distributive property. Well, go in the textbook, find the definition of distributive property and write it down. Right? You can use your textbook on this. This is a practice test, no big deal. Go to the next page. How about 19 and 20? How do we use the distributive property on those? I'll give you a couple examples. Here's one example. It says, rewrite using the distributive property and then evaluate. So here's the rewriting. First number times the second number. First number times the third number. Then evaluate. This is 30 plus 15, which is 45. Done. This is the kind of work they want you to do there. First number times the second number, boink. First number times the third number, boink. Then solve. What if they wrote it like this? Would that change the problem any? No. Just because they put the 5 here instead of here, the problem is still the same. 5 times 6 plus 5 times 3, and ultimately it ends up being 45, just like before. All you really do is if you see the number here, just erase it and put it out front here and solve it the same way you did up there. How about 21, 22, and 23? They're looking for you to write down commutative, associative, distributive, or identity. Do you remember what all those are about? Hopefully you do. If I wrote the following, 6 plus 0 equals 6, that's identity property, because a number plus 0 equals that same number. Or if I wrote 6 times 1 is 6, this is also identity property. This is the identity property of multiplication. This is the identity property of addition. Both ways, they're identity properties. What if I wrote 6 times 2 equals 2 times 6? That's commutative property, right? Because all we did was flip the numbers around. What if I wrote 6 times 2 times 3 equals 6 times 2 times 3? And I group them differently. 6 and the 2, 2 and the 3, I group them differently. That's associative property. Right? How about 24 and 25? Do you know what a arithmetic sequence is? A geometric sequence or a neither sequence? Here's an arithmetic one. 1, 3, 5, 7. We're adding 2 each time. So the next 3 numbers in the pattern would be these. What about this one? 2, 4, 8, 16. That's a multiplication pattern. We're multiplying by 2 each time. So the next numbers in the pattern would be 32, 64, and 128. This is arithmetic. This is geometric because it's multiplying. Arithmetic, geometric. What would it be an example of a neither pattern? Well, how about 1, then 2, then 4, then 7, then 11. I added 1, then I added 2, then I added 3, then I added 4. It's not adding of the same number each time. It's increasing the value of each number each time. This would be a neither pattern. Let's jump down to where it talks about milligrams and grams, or meters and centimeters. If I have 3,000 milligrams and I want to change that into an amount of grams, I have to go to the bottom of page 39 and look at the left-hand side and see that 1,000 milligrams equals 1 gram. And then realize I'm dividing by 1,000 to go from here to here. So I divide by 1,000 and I get 3. Or I'm moving the decimal point 3 places over to create this number. So I move the decimal point over 3 places to create this number. That would be one example. How about if I have 5.2 meters and I wanted to turn that into an amount of centimeters? Well, I go to the bottom of page 39, look at the left-hand side, and I'd see that 1 meter equals 100 centimeters. So moving from here to here is multiplying by 100. So that makes this, it has to be 520, because 5.2 times 100 is 520. Let's show you that. 002, 0005, because this is the automatic 0, and then 0025. The original problem has 1 decimal place value, so I count over 1 spot and put in the decimal point, 520. Now we've got scientific notation problems. In the first section, you're changing from scientific notation back into standard form. What if I had something like this, 1.45 times 10 to the 4th? All I have to do is take this decimal point and move it 4 places. I'm going to add a few zeros. I'm going to move it 4 places. Ready? Here we go. 1, 2, 3, 4. I move it to here. I rewrite it underneath, but I ignore these zeros, right? I ignore those, and then I put in the comma, counting from the right side, 1, 2, 3, 14,500. I move the decimal point 4 places to the right, 14,500. Or what about changing from a standard form number like 7,600 to scientific notation? That's a little bit different. This time we realize the decimal point's right here, and we move it to a spot so that we create a number between 1 and 10, and then we multiply it by a power of 10. In this case, the power of 10 is 3. 7.6 times 10 to the third power. 7.6 times 10 to the third power. Okay? That's the kind of work for today. If you get stuck, talk to me. Bye.